Here we're looking at the solution for number 1. The cost of 5 pencils and 2 pens must be at most $4. Be sure you label your x-axis. I use the cost of a pencil to represent x, and I use the cost of a pen to represent y. So you want to make sure you have a graph that's labeled. Notice when we put this into slope-intercept form, we subtracted 5x. That's why it's negative 5x. We divided by positive 2. 4 divided by 2 is my y-intercept. Negative 5 over 2 is my slope. Now, in this situation, since I'm starting with a y-intercept 2, and I'm looking only for cost of a pen and a pencil, I did go ahead and divide negative 5 by 2 and get negative 2.5. This allowed me to really focus on the first quadrant solutions. So you see that each graph mark on my graph is 0.25. I just labeled every other one with 0.5 so that when I applied the slope of negative 2.5, I went down 2.5 over 1. I used the same scale on the x-axis, 0.25, 0.5, 0.75, 1. So again, we're looking for the cost, and we're looking for a positive value. And reasonable solutions for this would be an actual cost of a pen and a pencil. I wouldn't expect one of your reasonable solutions to have a value of 0 for one of those costs. I have put several reasonable solutions. This solution, 0.5 and 0.75, is on the line and would give me an exact cost of $4. These possible solutions, 25 cents and 75 cents, 25 cents and 50 cents. You can see those are in the shaded region and would give me a cost of less than $4. So with you only focusing on the positives, you really wanted to be able to zone in on that small solution region in the positive quadrant. And the only way you could do that here is to use a very small scale. Number 2. Sarah can spend at most $7.50. So again, this is a less than or equal to whenever you're spending money. That amount that you can spend is a maximum. I'm using X to represent the amount of broccoli bunches that she can purchase. I'm using Y to represent the number of packages of carrots that she can purchase. Here we have 1.25x plus 0.75y is less than or equal to $7.5. I solved for y. Instead of putting a decimal here when I solved for y, the slope was negative 125 over 75. If I multiplied 1.25 minus 1.25 over 0.75, so we subtracted 1.25 and then we divided by 0.75. You could just put that into the calculator, but you're going to get a repeating decimal and you're going to find that difficult to graph. So what I did was I multiplied the top and the bottom by 100, which basically moved the decimal twice, making it 125 over 75, and then I could divide the top and the bottom by 25, giving me 5 over 3. So that's how I came up with my fraction negative 5/3. 7.5 divided by 0.75 is 10, so that was easy to use the calculator for because that gave you a whole number for your y-intercept. So I started at 10 and I went down 5 over 3, down 5 over 3. I used a scale of 1 on the y-axis. I used a scale of 0.5 on the x-axis for no other reason other than to show you that you could use a different scale on either axis if you want to. You just need to make sure you label appropriately what your scale is. So you can see that anything in the highlighted area would be a solution, or because we could spend exactly 7.5, we would have a solid line, and anything on the line would be solutions. So she could have bought 3 packages of broccoli and 5 packages of carrots. That would be a reasonable solution. 2, 5 is a reasonable solution. She would have had money left over. 3, 3, or 3, 4 are reasonable solutions. You know, depending what she's doing with the vegetables. You know, maybe you don't like broccoli as much, so you're only going to get one. You're going to get 2 packages of carrots. You know, that's a reasonable solution. I would not go with 0, 0 as a reasonable solution, and I would not use a decimal as a reasonable solution because you can't buy a portion of a package of carrots or a portion of a broccoli bunch. Non-reasonable solutions would be any positive thing outside of the shaded area. She could not buy 7 broccoli and 10 carrots. She would not have enough money. So that would not be a solution. Looking at number 3, you'll see a common theme with the first 4 questions. You have at most $6 to spend. So here is our less than or equal to $6. Again, dividing to come up with the slope was tricky. I didn't want 0.8 as my slope. I left it as a fraction because that made it easier for me to apply a rise over run as if I had a fraction. So if you look over here where I simplified the slope, 2 over 2.5, so get rid of the decimal, move the decimal once to the right in the top and the bottom. That's equivalent to multiplying by 10. So that's 20 over 25. 20 over 25 divided by 5 is 4 over 5. So that's how I came up with -4/5. I left the y-intercept 2.4, but I didn't use the y-intercept in my graph. To find the x-intercept, substitute 0 for y, and you would get 2x is equal to 6. Therefore, the x-intercept is 3, 0. That was very helpful when I graphed this because I could start at a whole number, 3, 0, and then apply the slope of -4/5. -4/5 is down and to the right, so going the other direction, I went up 4 and left 5. I see now I made a mistake because I did not, oh no I didn't, I did not apply my scale, but I did because I went up 1, 2, 3, 4, and left 1, 2, 3, 4, 5. Notice that next point that I plotted did go off the graph, but that's okay. I just used that point to draw my line, and then when I shaded my solution region, I only focused on this little triangle right here that would represent the possible solutions. So here I've listed some possible solutions. Notice I did use decimals here because we're talking about pounds of olives, so I assume this is something where you can get out as many as you want, as many pounds as you want, or they weigh it when you go check out. So I used, you know, she could have 0.5 and 2 if she preferred black olives over green, or she could have 2 and 0.5 if she preferred green olives over black, or she could have 1 pound of each. All right, so those are some possible solutions. And number 4 was a little simpler because we had all whole numbers here. It was easy to subtract x and see that y is less than or equal to -x plus 16. Started at 16 on the y-axis. Notice I did go down 1 over 1. It's just that my scale looks different than yours probably does because I went up by 2's on the y-axis. I was short on space vertically, but I had plenty of space horizontally. So I went up by 2's on the y-axis. I went over by 1's on the x-axis. So this box right here represents going down 2. This represents going over 2. And -2 over 2 is equivalent to -1. So when you look at your solution region, you should have all the same solutions that I have as possible solutions. 6, 10 would be having exactly 16 cups. 10, 6 would be having exactly 16 cups. I would prefer this because I like orange juice more than pineapple juice. Obviously, you could have a little less than 16 cups.